In this video, we're going to look at writing quadratic functions. With our vertex form, the vertex form of a quadratic function is y equals a times x minus p squared plus q. If you know the x-intercepts, do you have enough information to write the equation? The answer is false. There can be infinitely many quadratic functions that have the same two zeros depending on the value of a. So in this picture, you can see that all these quadratic functions have the exact same zeros, but they're all different. So we're going to determine the function that defines the parabola and write the equation of the function. First off, I see that vertex, and I'm going to be using that vertex form. And if I know what that vertex is, which is 4 and 2, I can plug that into my equation. So right now I still have three variables. I have y, a, and x. Now I need to figure out what a is. I can't just grab that from the graph. But if I look at my other variables, y and x, I can find a y and x with that graph. So if I just use any kind of point, I can plug that into my equation and solve for what a would be. So I'm going to find a point along my graph that goes through a nice intersection. So this one here is the point 6 and 8. So I'm going to substitute 6 and 8 into my x and y. So y is 8, x is 6. And that way all my variables are filled and I can solve for a. Okay, so 2 squared is 4. I'm just going to rewrite it so that 4 is in front of the a. We always like to write it so that our number is in front of the a. And then I'm going to move over that 2 so I can get a by itself. And I get my a value is 3 over 2. So my final equation is y equals 3 over 2 times x minus 4 squared plus 2. Here's my next example. I'm going to try and figure out that equation using the vertex. So that's the first thing I use. Vertex is 4, negative 6. So in your equation, I'm just going to write it all out, replacing our p value and our q value. Remember that that p value is opposite. Okay, here I'm just going to use a x-intercept. So this point here, 0 and 0, would be the easiest to use. So I'm going to substitute that in for x and y. That way, oops, and x. That way I can solve for a. All right, so negative 4 squared is 16. I'm going to put that number in front of my variable. And I get that my a value is 1. So I'm going to rewrite my equation out. I know what a is, I know what my p value is, and I know what the q value is. There's my equation. Okay, this vertex is an x-intercept. This is happening at the point negative 1 and 0. Make sure to plug in that p-value so that is opposite. I'm going to have to find a different point. Looks like my graph goes nicely through the point 1 and negative 8, so I'll use that point. Two squared is 4. You can continue writing that plus 0 if you want, or drop it. I'm just going to drop it. And I get that my a value is negative 2. So I'm going to rewrite the equation out. A value is -2, P value is 1, and that Q value is 0. You can add in the +0 or leave it without. The vertex of a parabola is at 4 and -12. This parabola passes through the point 13 and 15. Determine the function for the parabola in vertex form. So this one is not giving us a picture, but it's giving us all the information we need, a vertex and a point. So I'll put the vertex in. P-value needs to be opposite, so I'm going to write it as a -4. And then I'm going to replace my y and my x with that point value. So y is 15, x is 13. And then get a by itself. Nine squared is 81. And 27 over 81 is simplified to 1/3. So there's my a value, 1/3. So my equation is y equals 1/3 x minus 4 squared subtract 12. So here are some key notes. You can write the equation of a quadratic function in vertex graphing form if you know the coordinates of the vertex and one other point.